Thanks for joining me today, and I'm going to be talking about history of authentication. So first I want to thank the sponsors and a volunteer who Lacey just left, but I know how much work it is to put on a conference, and it couldn't happen without the time of the organizers and the money of the sponsors. I'm legally obligated to thank Amazon, Capital One, Dell, and Downtown Denver Partnership, so thank you. And thanks to all the other sponsors. There's a lot. Again, this is a big event, and I hope you've all enjoyed Denver Startup Week. I also want to say thank you to Quizlet. They are the track sponsor, and this is the developer track, one of 8 programming tracks. There's a code of conduct enforced, and if you're interested in finding out what that is, you can check out the website. I checked it out, and my TLDR is don't be an a-hole, basically. But if you want the full legalese, you can check it out. You might get photographed or recorded if you ask a question, especially, and you can feel free to tag away if you're doing anything with social. There's the Denver Startup Week tag and my handle, and then Infusion Auth as well. If you have questions, please just ask. I'd much rather this be a conversation between us than me talking to you for 45 minutes. Real quick about Fusion Auth. I just want to do this because they pay my bills. We're an authentication service, so something similar to Auth0. And what we do is we take things that are critical functionality for most applications, but are undifferentiated off of your developers' plates so they can build the features that your users actually want. I always say no one ever said when they log into an application, I love that login page, right? Everyone wants to get through to the actual features. Real quick about me, who cares? Again, you can look at me on Twitter or LinkedIn. Dan Moore Boulder will bring me up. There is a football player, Dan Moore. I am not that football player. And that's the end of the housekeeping. So let's kind of jump into what authentication is, because before we look at the history of something, we need to know what it is. It actually comes from the Latin word authenticatus. Again, things that I learned researching this talk, which basically means to verify or establish the authenticity of something. Now, authentication can happen for all kinds of things, right? Coins, stamps. If any philatelists in the room? Anyone know what a philatelist is? Someone who collects stamps. It used to be bigger when I was a kid than it is now, I suppose. You can authenticate art, but what we're going to talk about here is user authentication, right? So knowing someone is who they say they are. It can happen in the offline world, right? Or meat space, as I call it. And it happens with passports, right? This is where a government verifies who you are and then give you a document. You can present it to other people and they can rely on that. It can also happen in a less formal way, right? The Boulder Public Library doesn't do a whole lot of checking when you go in and ask for a library card. They basically will hand them out to most anybody. And at the same time, that is something that I can present at the library when I want to check out a book. So it authenticates me. The possession of that authenticates me. Incidentally, if you want to take a trip back to the internet in the year like 1999 or 2000, then you should check out this librarycards.tripod.com. It's a pretty cool website. This guy has actually collected, I think it's a guy, a student has collected library cards from across the Western United States. So if you want to see what a library card looked like from Bend, Oregon, or somewhere in Northern California, you can check out that site. It was a trip back down memory lane for me. It also happens, authentication happens online too, right? And that can be with a typical username and password like we have here, or it can be with something more advanced like a retinal scan or some kind of biometric authentication. So authentication happens both in offline and online worlds. There are 3 main categories of authentication, 3 main types. And the first is what you know, and I don't know about you all, but that guy has such a devilish look in his face. He obviously knows something. It can be something that you have, so that can be like a hardware token or a phone or a YubiKey. That can all authenticate you. Or it can be something that you are. So that could be a handprint, a fingerprint. I mentioned a retinal scan. Even something like your gait can uniquely identify you. So there are a couple of related concepts that's worth outlining when we talk about authentication. The first is something that's upstream of it. and that's called identity. So identity is the thing that authentication is actually trying to verify the integrity of. So that's who you are. And then downstream of it is authorization. So in most applications, you want to have certain people have access to certain things and other people have access to different things. But in order to control that access, you actually need to know who they are before you can do any kind of authorization decision making. So it's, I saw a talk recently that talked about like the IAM waterfall, which is identity is first and kind of upstream of everything. And you need to have some way of managing it. Then authentication, which actually verifies it in certain contexts. And then authorization, which plays off of authentication. So we've just covered kind of in 5 minutes a brief overview of what authentication is, what types of authentication are, and what the IAM waterfall looks like. But let's talk about when user authentication started. And this is really kind of the meat of the talk. So we're going to go back. And when I say go back, I don't mean start me up, go back. Anyone get that reference? Good, good. I should have played something, but we're not talking about Windows 95. We're not talking about the Apple II, which I don't actually know what the right music reference is for that. Maybe something from the Bee Gees. We're not even talking about CTSS, the compatible time sharing system, which was the first multi-user computer system in the 60s at MIT. We're gonna go way back. Let's talk again about the physical world, or to use my meat space joke. So let's go back to 3500 BCE. So this is almost 5,000 years ago. And this is kind of the first instance of authentication that I was able to uncover in my research. And it was a seal. And so the seal is over here on the left, and a document that has been attested to that the seal has been placed on, the document is a clay tablet, is on the right. And so what happened is the king or the monarch would hand out these seals to his representatives. And then if there was a contract, if there was a treaty, if there was a discussion where he needed to be present or his representative needed to be present, the seal proved that they were there. And so this is the first form of authentication that I was able to find. And obviously the factor or the kind of it is, the type of it is what you have. Having this seal authenticated you as a representative of the king, and then applying that seal made sure that the document was, had the blessing of the monarch. Step forward a couple hundred years, and we have the first known instance of a human fingerprint that was placed kind of intentionally, right? Obviously, there have been fingerprints for hundreds of thousands of years. This was in the Indus Valley civilization, and again, it was on a clay tablet. Unfortunately, there was not a lot of there's not a lot of understanding of what happened with this civilization, so we don't know why they did this, but it was pretty clearly done to kind of mark a contract in the same way. Had a couple thousand years, and we have what I found was a really interesting concept. And this is an example of authentication that is not just tied to a person, which is usually what we think of authentication, right? You usually think, okay, it's my password, it's my phone, whatnot. This is a way to authenticate a group of people. And what happened was there was a battle, as happened often in those days, and this was recorded in the Bible. And the Ephraimites and the Gileadites were fighting, and the Ephraimites were losing, and so they wanted to retreat across this river back to their homeland. And the Gileadites obviously had an interest in not allowing them to head back, and so they were trying to stop people at the border, at the river, right, the river crossing. And obviously, if I'm an Ephraimite and a Gileadite comes and talks to me, I'm going to say, and they say, are you an Ephraimite? I'm going to say yes. I'm going to say no, right? I'm going to say I'm a Gileadite because I don't want to die. But the Gileadites figured something out. They figured out that you could actually ask the Ephraimite to say a certain word, and that word would identify which group they were part of. And the word was shibboleth. And so an Ephraimite would say Sibboleth, and they couldn't say shibboleth. And so this was a way for the Gileadites to basically authenticate what group member this random soldier was part of. And unfortunately, if you said Sibboleth, you were killed. So next time you complaining about like resetting your password because there's been a data breach or something, just remember that authentication could have been a lot worse than it was back then. So let's step another 1,000 years or so ahead. And we now have the first instance of a passport. So this is, again, from the Bible. There was a Persian emperor who granted basically a passport to one of the, I think his name was Nehemiah, and basically it was safe passage through other lands that were ruled by this emperor. And it was another example of like an authentication factor where you were holding on to it and that proved who you were. In 200 BCE, we actually have a record of the Chinese using fingerprints or handprints in criminal cases. So they were actually authenticating like who the criminal was or other interesting things from the handprints. So they were recording those. In 30 BCE, we actually have an instance of something that's going to kind of play throughout the history of authentication. It's called a watchword, or it's a shared secret. So the idea is you have these Roman soldiers that are out there in these foreign lands, and they walk the perimeter, and they need to make sure that when they meet another soldier, that soldier is not someone who's not a Roman soldier, right? Not a member of that legion, because it's possible that someone could have come in and killed the soldier that was walking the perimeter and then dressed up as them. So what they did was they used something called a watchword. And how it worked is there was actually a Roman soldier that was part of each, I want to say centurion, or each century, called a tesserarius. I looked this up. And they had a wooden block which had words on it, and that wooden block rotated over time. And then they would share that word with the members of the perimeter walking, or with the guards. And then the guards, when they were out walking the perimeter, they would present that watchword. So this is an example of a shared secret. And this is something that comes up again and again. Wait, I'm going the wrong way. You have an owner of something, and it has to distribute those out of band, and then they can be, the secret can be used to for other parties to authenticate themselves. So this was a watchword, and this is something that the Romans, I'm pretty sure it happened beforehand, but this is the first recorded instance I could find. Any questions so far? Don't ask me any Latin other than the Latin I already mentioned, please.
I'm assuming you're familiar with the XKCD Shibboleth comic strip?
I haven't read I've read the Battery Horse something staple for passwords, but I don't know, is there a Shibboleth contract?
Basically comes up with shibboleth as a word you can say to tier 1 tech support to instantly get escalated to tier 2.
That's awesome, because you know your way in.
And then he wakes up and realizes it's all a dream.
Wait, does he say shibboleth or sibboleth?
Well, he says shibboleth.
Shibboleth. Oh, nice. That's awesome. One thing, actually, and this is not authentication related, but there is an XKCD comic for everything, by the way. There was, so thank you. I could have used that, actually. I should have. In the year 200, we have passports that are issued by the Chinese, and they actually have identifying characteristics for the first time. So it's not just the holding of the passport anymore, it's tied to who you are, right? Like how tall you are, what color eyes you have. In 940, so previously we were talking a lot about authentication in the context of death and dying, or war, or travel. Now we start to get into the third major desire of most people, which is, I guess, life and travel, our desires of people, money. So this is the first instance of the check that I was able to find, and this was happening in the Islamic Empire. There were merchants who were traveling around, and they obviously didn't want to travel around with all their money, but they still needed access to funds to buy things. And it's called a sack, I believe is the way it's pronounced, and that's actually what they believe the word check came from. So it's basically a way to draw money from other people. And I did a fair amount of research on this, and I wasn't able to find out how they authenticated, but I'm sure that given the sums of money that were that were involved, and the fact it was strangers coming through, they had some way of authenticating. In 1414, we have the first passport in England. And this was Henry IV who issued this, and basically it was given to foreign nationals for free, or if you were British, well, English at the time, you had to pay, and it gave you safe passage throughout various lands in England. In 1717, excuse me, we have the first check. The first pre-formatted check. This is not it. This is from 1975, but the Bank of England issued this, and it was on special paper. It was numbered, and the reason for that was checks were useful enough that they wanted to start to. People were starting to use this. And back in this time, you actually had to go to the bank to get the check, and then you had to go to the bank to cash the check. And there was verification that happened at that time for that money. In 1762, we actually have an interesting case where this is the first case I was able to find of a check kiter, right, of a forged check. And this was Price versus Neal, about 50 years after the pre-formatted checks were created. And what happened was somebody forged a signature on a check, and then they presented it to a merchant or somebody who cashed that check. And what was interesting to me is that when you have this situation where you have a check that's been forged, you need to make a decision on how or who is going to bear the damages, right? It could be the forger, obviously, would be the best person, but it's kind of hard to find them. They don't have any real interest in being found. Then there's a person who wrote the check or whose name was forged, and then there's a person who cashed it. And here is, they actually made the legal decision that it was the drawee, the person who cashed the check, who was going to be legally responsible. So if you wonder why, if your credit card gets stolen on the internet and you only owe $50 and everything else is borne by the bank, it's in part due to this legal decision from hundreds of years ago. In 1858, we actually have the first instance of a fingerprint being used for a contract in the Western world. This was actually Sir William Herschel from Britain, and he was in British India, and he used this method of fingerprinting to have contracts that he signed with the natives of India. 1903, we have the first driver's license in the US. And these were purely for identification. So there was no driving test required at all. Cars had been only invented less than 2 decades beforehand, but Massachusetts and Missouri were the first states to require a driver's license. 1906, we actually have, actually it's the question for y'all. How many of you all have been authenticated with a security question before? How many of you like that? I hate it. I hate it because the idea is that there's this secret out there that's that you don't have to provide, that they can somehow find out secret data about you, right? Like some institution, bank or whatnot. And the unfortunate truth is that now we don't actually, we don't have the privacy around our data to know that can still be secret. Anyway, the idea was in 1906, this banker spoke at a banking convention. He was a Baltimore banker, and he said that they used security questions that were information about a person that was not, that the person did not provide, right? There was some aspect of the person's data that they could find out otherwise. And they use that as an additional check. So when someone came in and signed a check, or cashed a check, they would also not just require a signature, but a security question. So that is an example of a multiple factor authentication where you have kind of defense in depth. And do not ask me what the land speed of a European swallow is, please.
Was that the first example you found of multiple authentication?
I think that you could make the case that the passport, the Chinese passport, where they had identifying characteristics, was actually multi-factor authentication too, because it had like characteristics and also like you held the passport. So.
It was totally Aladdin. Aladdin was the first.
Aladdin. Totally. In 1914, we have the first kind of issued British passport. So anybody could apply, any citizen of the British Empire. And then in 1944, we have an interesting case where it's kind of a watchword plus a shibboleth. So we have the D-Day invasion of France. And obviously, just like when we were talking about the Ephraimites and the Gileadites, in war, authentication becomes even more important than it is when you're cashing a check. And the Allies came up with a system, and it's actually also called a countersign, where they said, they told all the soldiers, hey, when you confront somebody, say this word, and they're supposed to say back this other word. And if they don't, then you know that they are not on your team. And the words were flash and thunder. And so you would challenge with flash, and the response was thunder. And the reason why I say it's a watchword is because, again, it had that shared secret aspect. They had to tell everybody about it. The reason why I say it's a shibboleth is because they picked those words for a reason. If you know German, you know that saying the word thunder, if you're German, is going to be more difficult than if you're English. So that was another instance of kind of a group identity based on who they were. And actually another multi-factor authentication. So we've been talking about authentication in the offline world for the past 20 minutes or so. Now we're going to kind of move into the online world, because in the 40s and 50s, that's when computers, sorry, Charles Babbage, that's when computers became really prevalent. So one thing to be aware of is when you're talking about online systems, it's much more about access to data and access to functionality than it is access to lands or preservation of life. The other thing that I want to just kind of throw out there, and if anyone has any insight into this, I'd love to hear in questions or comments. I'm going to focus on the consumer space, because the military and the intelligence agencies are probably 10 or 20 years ahead of every date that I'm going to put down here. So in 1961, we have the first computer system with passwords. And so this is the compatible time-sharing system. It's at MIT. And there was a guy, I forgot his name, Fernando Corbato. And he realized that he needed to set up usernames and passwords. And so he is actually credited as the inventor of the password. And he did this basically by having everyone get a username, and everyone had a password that was stored in a file on the CTSS. And before this, basically authentication, when you wanted access to a computer, happened beforehand. If you got physical access to the computer, then you were authenticated by the guard outside the computer room. But here you actually had, it was a time-sharing system, so you had multiple people who want to get access to it. And in 1962, anyone have any idea what happened in 1962? Other than the Beatles, probably on the number one. All right, 1962, we had the first password hack. So it didn't take very long. It took about a year. And this is actually an interesting story. So there was a guy named Alan Shear, who was a PhD student in Corbato's program. And the students were limited to 4 hours a week of computer time. And so he actually wanted more time. And so what he did was he figured out a way to get access to that password file. Now, he couldn't just examine it because it was protected, but he actually figured out a way to get it printed. So because they could print any file on the system, so he printed out the password file. The passwords were all in plain text, and he didn't actually do anything nefarious with it. He just wanted more access to the time. But he also did two interesting things. First is he actually shared it with the other students so they could get additional access if they wanted. And then second, 25 years later, he actually apologized to his boss for doing this. And thankfully, they did not take his PhD away. In '64, we have the first glimmerings of research into facial recognition. So this is where they actually take measurements, between my eyes, from my nose to my chin, whatnot, and use that to uniquely identify me. This happened, I think this was sponsored by, the term is a state agency, so we don't have any published research, but they were starting to do this. And what's interesting to me is that even back then, the computers were good enough and the algorithms were good enough that they were able to do geometric calculations, because when my face is this way, right, and the computer is over here, that's different than when my face is this way. And so they were able to actually do the geometric calculations and do the algorithms for the computer to recognize faces as they turned and had different orientations. In 1974, we have the crypt algorithm was invented by Robert Morris of the Internet Worm and Y Combinator fame. And so what crypt does is it lets you hash passwords. And this was included in Unix version 6. And what hashing does is it lets you take a word like password, run it through some operations, and get out a string. Anyone recognize what algorithm I used? It's actually MD5. I want it to be super crackable. But in general, the idea is that it's a one-way operation, right? So you can go from password to the string starting with 286 very easily, but you can't go backwards. Well, with MD5, you actually can in some ways, but that's neither here nor there. But the idea is that now what we can do is we can store passwords in a more secure fashion, right? Like, so we're not in the CTSS world where anyone who has access to the file can view everyone's passwords. We can actually take this, which this is an Etsy password file, and we can put in the hash values. And so if I'm an attacker and I get access to this file, I can see that Dan and Rickroll and Darwin have the same password, but I don't know what it is because I can't go backwards with that hash. So that was in 1974, and that kind of spread throughout the Unix ecosystem. In 76, we have the invention of publication of the invention of public-private key cryptography. And we're going to talk a lot more about that, so I'm not going to go into this here, but I did want to mention that that was what happened in 76. Incidentally, I was also... Actually, I don't want to say that. In 1983, we have an additional layer of security for passwords. And this was in the Etsy shadow file, which is basically a way for you to take the password file, and we're going to hide these hashes in a way, in a file that is not readable by normal people. So it looks more like this. And then the system is smart enough to know, okay, I know that we have an account for Darwin here, and I'm going to go look up the value of the hash in a different file. And so again, this is just a defense in depth strategy. We're just trying to make it harder and harder for attackers to find the passwords that people are authenticating with. Absolutely.
So sorry, with that, is that just basically a reference, and is it Darwin colon and a reference? Is that like a pointer?
I mean, it's like in concept, yeah. Yeah, I mean, basically the login program, which I didn't actually talk about this, actually, the login program is going to know, okay, I'm accepting the user Darwin, and then I'm accepting this plain text password in the login form, right? And then I'm going to go hash it and look up that hash value someplace. And if it matches, then the person's logged in and authenticated. Before the Etsy shadow, it would look in the password file, but after the Etsy shadow, it just knows to look in another elevate. Yeah, conceptually it's a pointer for sure. Yeah, good question. Any other questions, actually, while we're at that?
When was that rolled out, the shadow file? Because that was not, it happened after 66.
Sure, so the question is, when was that the shadow file rolled out? And the answer was, it was, the first I was able to find is like 83 in SunOS 4. So I do not know about, I'm sure there were other systems like, I don't know when it got rolled out to Microsoft Windows or something like that, but for Unix, it was 83 was the first instance. Cool. All right, so 1991 is when PGP was released. And so PGP was a shareware software. Does anyone know, does everyone know what shareware is, or do I need to announce that? Who doesn't know what shareware is? Okay, so kids, gather round. Before the internet, people would actually ship out software on like disk drives and CD-ROMs, and they would ask for people to pay them a little bit of money to get it there, because distribution used to be a real big problem. So that was called shareware, and I think it was called shareware because you didn't have to pay people; you just were asked to pay. Kind of like open source software now. Oh, no zing on that, huh? All right, so PGP. This is public-private key cryptography, and PGP existed beforehand, right? It had been invented in 76, but PGP is what made it accessible for the mass of geekdom. And what it solves is it solves the shared secret problem. So remember the watchwords, right? We have these two soldiers want to authenticate themselves to each other, and they do so by a third party distributing a secret to both of them. And then they can do that challenge response, or they can just verify that they both know the same word. PGP lets us solve it in a different way without this out-of-bound transmission of a secret. So let's kind of talk about what PGP actually, or what public-private key cryptography actually does. So if we have Alice and Bob, and Alice wants to send, or Bob wants to receive a message from Alice, but make sure that it is secret and that he knows that it came from her. Well, I'm sorry. Alice wants to send a message to Bob and make sure that only Bob can read it. Right now, Alice can send a message M to Bob, and unfortunately, an interloper named Charlie or NSA or what have you can get in the middle, right? And change the message or read the message. What public-private key cryptography lets us do is Bob can create a public key and a private key. And this is done via, I don't want to get too far in the math for two reasons. One is I don't know it that well. The second is that it's complicated, but basically it's multiplication of large prime numbers, or it's elliptic curves intersecting with planes in a multidimensional space. Both of those have ways where, again, there's you can combine, you can make calculations that are easy to go one way but hard to go another. So that's about, I'm going to say about the actual mechanics of it, but the idea is Bob creates a private key and a public key, and he puts up the public key on the internet, and he can publish it. Alice can find it in a lot of different ways. The point is anyone can see the public key. He doesn't care about that. But Alice can then encrypt a message with the public key, and rest assured that no one can read this except for the holder of the private key or the NSA. And so then Bob gets the message and he can safely decrypt it. So if Charlie intervenes again, and he can still, I mean, the message is still like being passed, right? Just an encrypted version of it. Charlie can't view the message. And so the whole idea is that previously, in order to do this, you would have had to have a trusted third party, right? That Roman centurion or some other analog of it. But now with public-private keys, because you can publish the public key, you can now have secrets be passed between people without any need for a trusted third party to hold a shared secret. And I didn't want to diagram this, but you can imagine that Alice could have a public and private key too. And so then you can have bidirectional communication that is protected. In 1993, we have the invention of the Lightweight Directory Access Protocol, otherwise known as LDAP, which was a refinement of a heavier, it wasn't called HDAP, it was a heavier directory protocol called X500, and it was invented in the University of Michigan, and basically it's a data storage system for user data and identities, as well as passwords that can be used to authenticate people. And it's interesting, this is 1993, but it's still in use today. Like I actually talked to somebody at a conference who has built, or that was part of a business that built a pretty big business just making LDAP more sane. So LDAP is still around. In 2004, we have the first, actually, I don't know if it's the first, it's the IBM ThinkPad with a biometric sensor on it. So that's someone's, I don't know if you can see that, but that's someone's finger reaching towards a touchpad where they can log in to their computer using a biometric sensor. And again, I imagine the military had something like this ahead of time, but I actually had a colleague who used one of these, and he said it was like a magic incantation you had to do to actually get it to work. You put your thumb on it 15 times, you roll it a certain way, but that identifies you. Don't sweat. Sounds like we have another veteran of that particular issue. Okay, so we talked about computers, we talked about the physical world. Now we're going to step in the world of the browser, right? In the 2000s, the location fills the new command line, which is a great essay by Daring Fireball, was published in 2004. Joel Spolsky was talking about how the Win32 API was being supplanted by the browser. This is Google Maps. This is Gmail. So we need to have ways to authenticate people via the browser, right? Via browser native things. And SAML was invented, or this is version 2 of SAML was 2005. This is a small portion of the SAML specification. There's my SAML joke I promised. Actually, I have no idea how, it's 800 pages. I've never seen it printed out. I'm sure it has been. But SAML solves the problem of authenticating a user in a browser context. So what happens is we have a browser over here. I'm going to walk through kind of a SAML workflow. And the nice thing about SAML is it allowed you to centralize authentication in a browser native way and still have some assurances about who was authenticated when in a distributed fashion. So we have the browser, we have a SAML IDP, which is fancy jargon for an identity provider. So this is a piece of software that talks SAML that knows how to authenticate someone. And we don't really care how the authentication happens. We just care that it knows how to do that and that it can create a SAML document and sign it. And it's going to sign it with a private key. We have the relying party, which is also called an RP. And the relying party is going to accept the assertion from SAML, which is basically a document from SAML, from the IDP, and it's going to verify the signature of it with the public key. So again, public-private key cryptography was really important to this. And the browser is going to be able to authenticate the IDP, and then one or more RPs can all rely on that assertion to make sure that someone has been authenticated. So that has a couple of virtues. One is you have one place for your identity store, right? Everybody logs in at the IDP. And the second thing is that you can add additional layers of complexity here, and the RP doesn't change. The RP still gets the same assertion. So if you start out with username and password, and then you move on to biometric authentication or multi-factor, or we're gonna call your mom and make sure you are who you say you are, it never touches the RP. The RP always just accepts the assertion. So how does this go? The browser says, hey, I want to access the application, right? And this could be a mail client, it could be CRM, it doesn't really matter. And the SAML RP says, who the heck are you? Please go ahead and log in. I don't know who you are. And it also says, go here to log in, right? Because the SAML RP knows which IDPs it trusts. So the browser is redirected. The IDP says, hey, or it says, can I please log in? It's not as polite, it's more HTML-y, but basically this is what's happening. And then the SAML IDP passes back a login form, and the browser or the user behind the browser actually authenticates. And again, we don't really care what happens here. It can be whatever level of assurance we actually need. Then the SAML IDP says, okay, I know you are who you say you are. I'm going to give you this signed assertion. It's signed with my private key, and you can go ahead and present that to other people. What does that assertion look like? This is one of the simpler forms I was able to find out there. It's complicated. It's long. This is the 2000s. It was XML. Right? XML was all the rage. So lots of information in here. And one thing that's worth noting is that you can have embedded keys, you can have additional attributes that tell us more about the identity of this person. Then the browser can now present that to the RP, and the RP can examine that session, make sure that it's signed by an IDP that it knows, make sure that the user has the correct attributes and roles, and they are who they say they are, and then hand back the actual application. So that is SAML, and frankly, that is web single sign-on in pretty much a nutshell. There was single sign-on before the web. There was actually computers before the web, believe it or not. But this is kind of prevalent now. And SAML was codified, V2 was in 2005, and it's still in use today. Like Fusion Auth supports it. We still find bugs in our implementation of it because it's an 800-page specification, but it is still very widely used, especially in the education, in academia. 2010. we're on to trying to, 5 years later, we're trying to fix the mistakes of SAML. This is OAuth 1.0a, and Flickr and Twitter and some other big companies use it. And in this world, instead of creating XML assertions, we're creating opaque tokens. And this is really, really useful for, again, think back to 2010, a lot of mobile apps, a lot of APIs. APIs are all the rage. And as far as I know, Twitter was like the longest user of this, and I think they were even using it until about a year or two ago. There was still an OAuth 1 implementation. In 2011, we have the codification of the time-based one-time password standard. Happened at the IETF. I think it's RFC 6708. Google can tell you that for real, but basically the idea with this is that you have a shared secret between two systems, and typically it's a long string, and then you have an algorithm which takes that shared secret and the current time and generates numbers. And so I can, when I first register with an application, create that shared secret. I can put it into my Google Authenticator, and then it stores it off as well. And then next time I log in, if I get challenged for this time-based one-time password, both systems run through the same algorithm, they have the same time, and hopefully they'll both end up with the same number. And so that proves that I have access to this shared secret without actually sharing the secret. Because if you share the secret, then suddenly it's all out there, as opposed to having this thing that rotates constantly. Now we're kind of on to the age of the phone. In 2011, we have the first fingerprint on the phone. This is the Motorola Ultrix, which, how many of you have heard of this? I've only heard of it because I researched it. It was not commercially successful, but it did let you put your fingerprint on the phone. 2012, we have OAuth 2, which tried to say, just like OAuth 1 tried to salvage or tried to correct the sins of SAML, OAuth 2 tried to correct the sins of OAuth 1. And one of the big things it did was it tried to make things simpler from an implementer standpoint. OAuth 1 actually had some cryptographic stuff that had to happen at the application layer and with the clients. OAuth 2 said, screw it, everything's gonna be over TLS. That's gonna be kind of our network security layer. But it also generated opaque tokens and was used for APIs. 2013, we have kind of commercial success for the fingerprint. And this was Touch ID, Apple, iOS, or I'm not sure which iPhone it was, but it could be used to unlock the phone initially, and then later it got expanded to more applications. What's that? S? Oh, thank you. Awesome. In 2013, also, we had password managers. How many people here use a password manager? Everyone should use Password Manager. And the nice thing about Password Manager is that you have to remember one password. And then you can have, basically it's a database of other passwords that you can have be crazy and long and unique, and you never have to remember them because you remember your one password, and that gives you access. All right, but so what happened is in 2013, that's the first instance of the password manager in the browser that I know. And so Chrome had it, Firefox had it around this time. And the reason for this made a lot of sense is because, again, the browser was the source or the host for more and more applications. 2017, we have the first commercial consumer-facing facial recognition. This was Face ID. Again, the iPhone, not the iPhone S, was the source of it. In 2018, we have WebAuthn gets codified. And so WebAuthn is a way for you to bring public-private key cryptography from the world of shareware and PGP to the consumer. And the reason that this works well is because it's supported by all the major browsers. And this little YubiKey or your phone contain a private key. And you can share the corresponding public key with, or one or more private keys, I should say. You can share the corresponding public keys with websites, and then the website can basically send down some stuff, and then the private key signs it, sends it back up to the browser, to the website. The website can verify it with that public key, and know you are who you say you are. And this is a huge deal for actual, it solves the password problem because you actually have this thing, either a physical device or a phone that has a private key. In 2019, we have the Colorado digital driver's license. So we've kind of come full circle from government IDs that were just on paper and driver's licenses that were just to identify people who could drive in the 1900s to something that is on your phone and available all the time and is functionally and legally equivalent to your paper or your plastic driver's license. In 2022, the Indian government had set a goal in the mid-2010s to give every Indian a digital identifier. And this ran across my newsfeed not too long ago. They have actually achieved that. So they have over 1 billion people with digital identifiers successfully. So, in conclusion, there's kind of 2 takeaways that I learned about authentication, and I'd be very interested to hear your takeaways. But the first is that authentication only matters if you have something to protect, right? Whether that's crossing a river or money or data. And the second is that authentication just is getting more and more complicated and is changing faster and faster. And so you just have to keep on top of this because it's the way to protect those things that are that you want to keep safe. And that's all I have. I am happy to talk about MoneyPython, the Holy Grail, or passwords, or FusionAuth. There's my contact information. We're hiring, and you can get FusionAuth for free if you want a full-featured SAML and OIDC compliant identity server. All right. Actually, the guy back there. Actually, I think I'm supposed to hand you a microphone, or Lacey will. Thank you. Let's preserve it for posterity, this question. All right, no pressure, no pressure.
Thanks for the presentation. I'm curious, as you're looking at the history of this stuff, would you make any predictions as what the next 5 years looks like for authentication?
Yeah, so it depends on what you mean by looks like, but I think it's going to become more and more embedded in our lives, and I think it'll become less and less something that we have to think about. I think that I already know there are people who've gotten themselves chipped, and yeah, for real, you can chip a pet, you can also chip a person. And I think I remember hearing on a podcast that it was tough to read. So the person actually had a hard time getting the chip read. But I think that is, which would be really awkward, right? It's awkward enough to forget your password. But I think it's going to become more and more embedded because there's more and more systems that we'll need to authenticate with. But it's going to fade in the background the same way that, I don't know whether you all enough to remember this, but I remember when you actually had to be concerned about when you called someone long distance. And I think that authentication, because they charge more for certain times. And I think the authentication is going to be something that just continues to fade in our background because it becomes more and more important, but there are more and more ways for it to be transparent. Do you have a question?
Yeah, I
Here.
was curious, and maybe you know.
Oh, go ahead.
You get all the mics.
All the mics. Yeah, I was curious, and maybe you don't know the specifics, but how does the Indian government handle if you lose your private key?
So I don't. I looked into this briefly, and it's not based on OIDC or any kind of standard. It looks like it's a combination biometric and a registration process. So I'd assume that there's some aspect of you present your thumbprint again or something like that. But
Gotcha.
I don't
To
know.
get a new one? Or,
Yeah.
Okay.
Yeah. Yeah, I would love to see a talk on this because I think that's just a tremendous, we don't have that in the US, right? And what a tremendous accomplishment across the breadth and width of the Indian subcontinent to get to that point. Great. Any other questions?
You knew I was going to ask something. Yeah. Hello? Oh, yeah. What got you into authentication?
What got me into authentication? Well, I tried to write my own many years ago, and got burned. Well, I didn't get burned. Well, here's the thing about authentication. Like, it seems so simple, right? Like,
Okay.
oh, just username and password. And I did that, and it was for an application that didn't matter very much. It was like a book club application. And I started to realize that it was difficult. And then I went away for a long time, and I treated authentication like I think most developers treat it, where it's like, it's kind of like a little bit like, what's another thing that's hard? Like
Coding in general.
well, coding in general is difficult, but I think that like authentication is one of those things. It's kind of like writing a compiler, right, or a state machine. Like you don't, or it's like this thing. You if you have to do it yourself, you figure it out as quickly as you can, and you do the minimum that you think you need to, and then you like run away. And that was certainly my experience with authentication. I happened to meet up with a friend who was actually running an authentication company. I wrote a couple of articles for him, just kind of showcasing that, and it got more and more interesting and more what's the word? Rich. There's so many edge cases, right? And so that's what pulled me to authentication.
Thank you. And last question from me, at least, is why should anyone work at FusionAuth, and what do you love about them? You said they're hiring, so shout out to everybody. Now you'll know why.
Thank you. Wow. I did not plant her. So I guess the thing I love about FusionAuth is there are a couple things, right? The first is that we're a small company, and just in my career, I've been drawn to small companies. No offense to anyone who works at a big company. Big companies are great. They work on big problems. They're hard, but I find that, how do I put this nicely? People can hide at big companies. And small companies, it's harder for people to hide at. Like, and I like the fact that like no one can hide at a company the size of FusionAuth. We're about 20 people right now. And I think the second thing is I love the fact that we're taking this hard problem of authentication, like that whole SAML thing, and we're basically taking it and we're making it accessible to people because we have this free edition, but we're also making it accessible in other ways. We're doing a lot of education, and even in our application, we actually use terms that developers would use as opposed to terms that are like identity-specific terms. You'll probably not find, I'm trying to think, I don't know if you'll find the word assertion in our like UI, because no one cares about the assertion. They care about like, how they actually can log in using this crazy, scary protocol called SAML. So those are two reasons. I will say the jobs are mostly, we have some non-technical jobs like sales associate, but mostly we're looking for senior Java devs. So, yeah.
I don't know how I got stuck with it. Who else? Sorry.
I hate microphones. Why Java?
Why did they use Java? I mean, I didn't write the software, so I can only speculate. It came out, so the original project, the original piece of software that FusionAuth came out of was actually something called CleanSpeak, which is a profanity filter that plugs into games and other kind of user-generated content. And that was started in, that code base, the roots of it were 2005. And I think the founder just knew Java. And then this spun out of that. I think that Java's, the honest truth is it doesn't really matter what it's written in, except for hiring, because everyone deploys via container now. And so it's just kind of wrapped up nice. But yeah, I mean, and Java sometimes gets a bad rap, just like JavaScript sometimes gets a bad rap. Like, they're both tools. I can talk for a long time about my opinions about software programming languages, but the honest truth is, for a big chunk of applications, it doesn't really matter. It's talent and the way that the language is applied that matters more than the language itself. Any other questions? Oh, great.
I know this is out of scope, but any thoughts on the future of encryption and quantum computing and quantum encryption?
Yeah, I mean, so for people who don't know, basically the idea is that a lot of the factoring that I talked about, which is what protects public-private key cryptography, there are quantum computers coming that can do calculations at a speed that So let me take a step back. That multiplication of two primes to protect the message from Alice to Bob happens. It's not impregnable. It just takes a long time for the calculations to be done to back out, right? The same with the password hashing, right? It's not impregnable. It's not like magic. It just takes a long time. And quantum computing they're making progress towards that. Those calculations taking less time, which would basically break the internet because TLS is part of public-private key cryptography. And if TLS was broken, then I guess people would still buy stuff on the internet because we're kind of dumb, and the banks would cover our losses, but the banks would shut things down pretty quick, right? So I guess I would say I think that the imperatives of war, money, and life will probably lead us to discover new kinds of cryptography that are more resistant to quantum computing. Oh.
I don't need a microphone, small room. So for just basic web use, and you're authenticating into like business apps, right? You log into this, you log into that. It seems like it's going toward OAuth. You see that everything kind of going away from individual username and passwords for a particular app. Just like, oh no, just authenticate through Gmail or Facebook or whatever. Do you see it continuing to consolidate to that, or do you see something else coming that draws use?
Okay, so
Sorry,
yeah.
the question.
I will not repeat the whole question because I'm not sure I got the whole question. Or I got the whole question, I'm just not sure I can repeat it. But yeah, so the question is, are we moving away from individual apps having their own user data silos towards more consolidation, whether that's with something like OAuth or OIDC or a social login like Google or a GitHub or that kind of thing? Is that a fair assessment of your question? Yeah, so I think that there's kind of two countervailing forces happening here. The first is, actually, it's a survey. How many people want more passwords in their life? Let the record show no one raised their hand. Yeah, so I think that is definitely pushing people towards single sign-on. And I don't know about you all, but I definitely will pay more attention to my Google password and account than I would JRandom site. So I think that it's that consolidation is actually more secure. Google's going to have more security engineers than JRandom site will. What's breaking it apart, I think, is actually some of the privacy implications and also some of the access implications. Every so often, I'm on a hacker site hacker sounds so fancy. I'm on a news site called Hacker News, and every so often someone will post and say, I lost access to my Google account, which controls my entire life, and I can't get anyone at Google to return my phone calls. And so with that centralization comes some cost. And then there's also, there's some changes coming to the browser. I'm a member, not an active member, but a member of the W3C Federated ID community group. And the browsers are pushing some things because everything that can be used for federated login around like OIDC and OAuth, where I get bounced between different browsers, I get bounced between the RP and the SP, that can also be used to track me. And the browser vendors are recognizing that, well, partly induced by, I think, the European regulators, but also on their own, that collapse of privacy is bad for users, and users are scared of that. So they're making some changes at that level. So I think that's going to kind of push people to run their own identity servers, but within a suite of tools, it'll be single sign-on. Does that answer your question? So I'm not sure who wins in that battle, but
That helps.
yeah. Do you mind if I get him since you've, great.
When you say single sign-on, are we talking, the thing I've heard a lot about in the last month, there have been two other people talking here about things like WebAuthn, password-less authentication.
Mhm.
And I also attended the Elixir conference at Gaylord, which was a couple weeks ago, and one of the guys had written a library for WebAuthn for them. So it's definitely seems to be the way to go. Is that what we're all talking about when we say?
Well, single sign. So the question is single sign? I'm not sure I understand your question.
Well, the WebAuthn stuff is for no password. It uses FIDO, and one of the guys couple days ago said, the big news is for this month, Apple is now going to be one of those devices, so you don't have to have something to plug in.
Yep.
And that's the big game changer.
Yep.
Half of your mobile apps, so your mobile phone can be that. And apparently Chrome is going to do it too.
Mhm.
It is already doing
Mhm.
it. So we don't need passwords anymore.
So here's the thing about,
Apparently.
well, I mean, so single sign-on is a little bit different. Single sign-on is about like that central server that authenticates you somehow, and then sign something so that other people can rely on it.
Like Okta.
Yeah, Okta's a great example. Yeah, I mean, Fusion Auth is a good example, but Okta's a great one too. Auth0 is a good one. There's lots of identity providers out there.
Well, that's more about letting your customer, if I'm a B2B, I'm going to let my customer log you in.
Well, I'd say single sign-on is more about like having a centralized thing that you don't care where the authentication happens, and it just provides assertions, right? Or like assurances. WebAuthn is about that authentication event. And I'll say that I think WebAuthn is really going to be great. What I've seen, and we haven't rolled it out, but we're working on it, is that the account recovery process is a little tough. And so I don't think username and passwords are going to go away, because how do you, if I log in with my computer, I use WebAuthn to log in with my computer, I can do that. It's awesome. Now, anytime I want to log in again, I have to use this computer, unless I have like a YubiKey or something like that.
No, the way the guy was explaining it, you could also use the phone.
Well, that's because Apple is doing the Apple thing, and they're going to be transmitting around private keys up to iCloud.
On some mutual.
Well, I just want to like be totally clear. Like you're basically like the whole point of public private key cryptography, and the strength of it is that it never leaves, or with WebAuthn, it doesn't leave your device, right? That means that you have assurances about it. But Apple, again, being Apple, is going to like have some way, and I'm sure they're going to encrypt it. I'm sure they're going to store it safely, but they're going to move that private key around, and that is.
On all your Apple devices, for sure.
Right, and that's a little worrisome to me, right? Because the whole point is, so anyway, WebAuthn, Apple aside, like it has some downsides. I think it's really great for re-authentication, right? Where I've signed in, and then I'm gonna set up my public key on WebAuthn, and then I can quickly re-log in, passwordless, really great. But I still think you need to have some other out-of-band way to deal with the fact that if this device gets water spilled on it, I don't want to be locked out of my account. Sorry, I'm not sure I exactly addressed your question, but I think WebAuthn is definitely coming. Of course, which is part of the fun. Yeah.
So NVIDIA gets one on TV probably 6 months ago. Was like, hey, we had a breach. We are implementing new technology for zero trust. If you are aware of how that is going to be rolled out, or the technologies that they're planning on using, or kind of elaborate on what they're thinking when they refer to zero trust.
Well, I can't elaborate on what NVIDIA is thinking. I can elaborate on my understanding of zero trust, if that would be helpful.
What they might be referring to.
Yeah, so I mean, the idea is that you can think of applications and systems as having a perimeter, and then you can think of it's kind of like a cream-filled donut, right? Once you get into that hard perimeter of sugary carbon, not carb goodness, like you get to the jelly, and there's no real structure inside the jelly. And that is the way the corporate networks were a while ago, right? You had a VPN to get in, and then once you were in, things were kind of like, you could go hog wild, right? And that worked fine in the world of 15 years ago or 20 years ago, but now people are using SaaS applications, and people want to be able to access the internet. And so the idea behind zero trust is that basically you don't trust anyone inside your network more than you trust someone outside your network. So you have to have authentication mechanisms, and typically it's like token based. And basically anytime someone wants to do anything in your network, you're not trusting what computer they came from or anything else. You're trusting what they held, and that's some kind of authentication mechanism, and you force them to re-authenticate, perhaps transparently, every time that they move around. So that's my understanding of zero trust. There is a paper that I got partway through that NIST wrote that's all about zero trust. If you want to like learn about policy decision points and policy enforcement points and some of the nuts and bolts of the architectural structures of it, I think if you just search for NIST zero trust, you'll probably be able to find it. It's a long PDF. Not as long as a SAML spec, but a long PDF. Oh, yeah, sure.
So they're also applying machine learning to that process in some way, trying to make it an NVIDIA type thing offering. Do you see that being like a combination of tracking where you're building and where you're supposed to be? And things like remote security, like physical security.
Sure.
Like looking at combining the smart card access with the localized tracking from the entrance to the door.
So yeah, so now I get to like some more, no worries. I mean, if you thought I was speculating when I was talking about quantum computing, I'm really speculating now. I think that probably if I was going to apply machine learning to security, I would look for aberrations, right? And so that could be aberrations in access, it could be aberrations in timing, it could be aberrations in location. And I think that's low-hanging fruit, right? Because the nice thing about that, thank you so much. The nice thing about that is that what's the downside? The downside is a little more user hassle, right? Like you make them authenticate again and then you're golden, right? If I am accessing a system and I access it from the US every single day and then suddenly I access it from Germany because I travel to Germany, well, all I have to do is authenticate again, but it's been flagged. Whereas if I'm actually not really in Germany, it's somebody else, then they're stymied. So I don't know what other advanced things they're doing with machine learning around that, but that's where I'd start.